Assalamualaikum warahmatullahi wabarakatuh and hello everyone. My name is Sharifah Amiza binti Muhammad Sharif. My matrix number B142510037. Our company is called Fivecore Incorporation and today we would like to talk about our product, pneumatic fruit and veggie slicer. Our agenda for today are organization chart, our mission and vision, Gantt chart, development stage, background, objectives, product planning, customer needs analysis, product specification, concept development, prototyping, testing, cost and time analysis, business canvas model, and lastly, conclusion. This is our organization chart. As you can see, I'm Sharifah Hamiza as a project manager, and my team are Ashraf as a industrial engineering unit, that is manufacturing or process engineer. Azim as a design engineering unit, that is design engineer. Afiq as a quality control unit or testing unit, that is QC engineer and test engineer. And lastly, Nur Fahana as a sales and marketing unit and purchasing. Our company mission and vision. Mission is to develop innovative and efficient solutions that improve productivity, quality, and everyday life. Our vision is to become a leading global company recognized for innovation, reliability, and modern industrial excellence. We move to our Gantt chart. As you can see here, our project is starting from planning, which is project briefing and discussion starting on week 3, generate ideas week 4, and we have meeting on 10/4/2026 for generate ideas. Market research on week 5, and we do problem statements and objective in week 6. Similar to benchmarking, mission statement, organization chart, and roles and responsibilities. Lastly, design logo for company. And we do customer needs analysis on week 7. And we have meeting on 30/4/2026. And then we move to the design phase. We generate AI prompt concept in week 7. And we have meeting on 27/4/2026. Next, we move to generate concept in week 8, concept selection in week 9, similar to concept selection in week 8, and final design 3D CAD drawing in week 9. Next, we generate BOM documentation in week 11, revise 3D drawing and BOM revise documentation in week 12. For this phase, we have meeting on 8/5/2026, 3/6/2026, and 10/6/2026. Next, we move to purchasing phase. That is purchase component and component arrive on week 30, and we have meeting on 60/6/2026. Next, the fabrication phase. We begin with 3D printing structural part and fabrication custom plates in week 13 until week 14, and blades and structural alignment, assemble pillars with base and mount the stainless steel blade, pneumatic actuator mounting, fix the air cylinder to the top plate to the rod end in week 14. And lastly, for the submission, we do report submission and documentation submission in week 15, that is 30/6/2026.
My name is Nur Farhana. So, development stage, this flow chart illustrates the structure stage of product development divided into two main phases, planning and development. In the planning phase, we begin with the market research to study trends and competitors. Next, we conduct the customer need analysis to identify what user truly wants. From there, we move into concept generation where multiple ideas are brainstormed. So the chosen concept is developed into a 3D design using SolidWorks. So SolidWorks allowing us to visualize the product before production. The design is transformed into a physical model through fabrication. Second phase is development plan. The product undergoes testing to check performance and safety. After that, components are assembled into a complete product. We inspect the product to ensure quality standards are met. Once approved, we apply finishing to improve appearance and usability. The process concludes with the creation of prototype, which represent the final version before the mass production. Our background is in the food and beverage industry. Fruit and vegetables cutter are widely used. The most common type is handheld veggie cutter, which is popular because it allows fast and uniform slicing, especially in high volume food preparation. This not only saves time but also improve food presentation. However, manual cutters have several drawbacks. They require significant physical force, which can cause fatigue and even repetitive strain injury. The cuts are often inconsistent. There is also a higher risk of finger injuries. To address this issue, our team developed a pneumatic fruit and veggie slicer. The system uses pneumatic cylinders, solenoid valve, air fitting, an air compressor, and a wedge blade. In background set the stage for our project, showing why innovative in slicing technology is necessary and how our pneumatic system provides a safer, more efficient solution. Our objective is explain the principle of product design and development, organize the product through the outcome of analyzed problem, ability to work effectively in a group to apply knowledge of entrepreneurship in the process of product design and development.
Next, we move to product planning. Product planning is divided by three that are market research, features, advantage, benefits, FAB, and lastly, pain points and gains. Okay, next, this is our market research. The market research was conducted using a survey involved 31 respondents. The respondents were chosen based on our target audience, and we blasting it to F&B industry and hospitality service. The survey results provide insights into current uses, current problem, product features, and purchase intention that helping to identify opportunities and support effective business strategies. As you can see here, this is the demographic info segment. The second one is current user segment. The third one is current problem statement. Next, product features segment. And lastly, the purchase intention. For this slide, the figure shows that the respondents' opinions about what will influence their purchase of this innovative product. The response will be a data collection to be our product specifications. Next, we move to features, advantage, benefits, FAB. For our product features is high volume cutting. The advantage be able to cut fruit and vegetable in a large quantity in a shorter time. The benefits increase productivity and reduce workload. For the second one, the features is easy to handle and operate. The advantage, simple operation with user-friendly design, and the benefits, reduce user fatigue and improves convenience. For the third one, more lightweight. The advantage is easier to move and transport. The benefits is enhanced portability and flexibility during use. The next one, safer than manual methods. The advantage is reduced direct contact with cutting tools. The benefits is minimize risk of injury and improves workplace safety. Efficient features. The advantage is perform tasks smoothly with less effort. Benefits improves overall work performance. The next one is time saving. The advantage is faster completion of cutting process. The benefits is allows user to complete tasks within a shorter period. And lastly, space saving. The advantage is compact and organized design. The benefit is suitable for limited working areas and easier storage. Next, for the pain points and gains. Based on our market research, we analyzed that pain points that customer experience is required more effort while using manual cutting. The gains we produce is reduced physical effort with pneumatic system technology. The pain points, low productivity and slow cutting process. And the gains, faster cutting and higher productivity. Pain point, inconsistent cutting size and quality. The gains, uniform and accurate cutting results. Next is risk of hand injuries from manual cutter, and the gains, improve safety with protect cutting system. Next, time consuming operation, and the gains, time saving and efficient operation. And lastly, poor after sales support for manual cutter. The gains is reliable system with better service.
Hi, my name is Muhammad Arifashro bin Saifubari and my metric number is B1425110. I'm from BMID section 1. Safety was another critical concern. Customer wanted a device that is more safe and efficient. To address this, our engineering statement specifies that the device must include safety guards that guarantee zero finger access gap to completely prevent blade contact, all while maintaining a cutting efficiency of less than 95% gap. Furthermore, to ensure the unit is a compact, portable, lightweight, we set the physical limits, a compact footprint of 200mm by 690mm and a total mass of less than 5 kilograms. Finally, to ensure the brand trust, we committed to maintaining 95% product consistency during operation using a robust pneumatic system technology. Now, if you direct attention to the right side of the slide, you'll see our needs hierarchy. We structure this prioritize into a pyramid format. At the very peak of our pyramid, we place a time saving and efficiency as the absolute drivers of our customers' satisfaction. This supported by safety, space saving and lightweight structure. At the foundation, ensuring everything function reliable, consistent and using a technology. So, how do we bridge out the gap between what the customer wants and what we actually put? We do this using a classic system engineering tools, the house of quality. The house of quality metrics allow us to cross references our prioritized customer requirements on the left against our actionable engineering characteristic at the top. To do this, we establish relationship strength. A solid black circle represents a strong relationship between 9 points. A square represents an average relationship value at 3 points. And open double circle represents a weak relationship value at least a 1 point. By mapping these relationships, we can calculate the raw score and relative weight for each of our engineering parameters. If we look at the bottom rows of the metric, the results yield a very clear path. Cylinder bore and size and A pressure type for the rank 1 position, each commanding a relative weight of 25.9%. This is incredibly logical. The cylinder bore directly determines the force of the cut, while the air pressure controls the cycle speed. Together they dictate both the time saving and efficiency of our mission. Safety switch rank as a rank 2 with a relative weight of 24.7% because safety was tied as a top customer priority. Integrating a highly reliable physical safety switch is essential to our engineering architecture. Lastly, the blade matrix and total weight type for the rank 3, each with a relative weight of 11.8%. Although they are ranked lower, they remain vital to ensure the durability of the cutter and keeping the overall mass under our 10 kg threshold. In total, this house of quality ensure that over 50% of our engineering focus in a concentrate precisely on optimizing the pneumatic cylinder system, directly delivering the speed and power our customer are asking for. Having established our needs statements and hierarchy, we needed to validate this assumption mathematically. This brings us to the next our slide, represent to important ranking, where we look our quantitative importance ranking. To truly align our engineering effort with user desire, we ask our target market to rate these attributes on the scale from 0 to 5. The bar chart on this slide displays the clear consensus of our audience. So, for the first, time saving and safety features tied for the absolute highest priority, both achieving a maximum score of 5 out of 5. This tells us that if our device is fast but unsafe, or safe but slow, it will fail in the marketplace. These two parameters are non-negotiable. Follow closely behind efficiency and consistency, which is tied with a strong score of 4 out of 5. Our users expect a professional grade slice every single time they pull the pneumatic lever. Space saving ranked as the lowest priority of the 5 with a score of 3 out of 5, while portability is a great value. Users are willing to sacrifice a slightly larger countertop footprint if it means they get a machine that is fast, safe, and consistent. Understanding this exact breakdown allowed us to make highly informed design trade-off in the next phase of our development.
My name is Muhammad Rafiq bin Muhammad Fahmi with metric number B142510022. Next, I will explain our product specification. After identifying customer needs through market research and house of quality, we translated those requirements into measurable engineering specification. This specification allows us to compare our product and existing product and ensure that it meets the expectation for safety, efficiency, durability, and performance. The specifications are divided into 3 sections: the physical specification of the product, the performance specifications, and the benchmarking with the existing product. This slide shows the physical specification of our pneumatic fruit and veggie slicer. The machine measures 200 mm in width and 690 mm in height, providing a stable structure while maintaining a compact footprint. The total weight is 5.5 kg, making it durable yet still suitable for commercial kitchen use. The pneumatic system operates within working pressure of 22 to 145 psi, giving it a wide operation range for different cutting requirements. Our slicer can handle fruit and vegetable up to 450 mm in height, allowing larger produce to be processed. Finally, the wedge blade is made from fruit-grade stainless steel, which provides excellent corrosion resistance and durability and hygiene. This slide focuses on the performance improvement compared to manual cutting. Our slicer completes one cutting cycle in approximately 3 to 5 seconds, whereas manual cutting usually takes around 10 to 15 seconds, making it 60% faster. This results in approximately 3 times higher productivity, producing around 720 slices per hour compared to only 240 slices per hour manually. The pneumatic system also minimizes the physical force required, reducing wrist and shoulder strain while producing consistent speed and uniform slices. This slide explains the efficiency and power supply of our product. Our design reduces food waste to less than 5% compared to approximately 10 to 15% with manual cutting, presenting around a 50% reduction in waste. Because every slice is uniform, the overall food presentation is significantly improved, which is specifically important in commercial kitchen. To evaluate our design, we compared it with several existing products currently available on the market. The first two products are manual slicers that are inexpensive but require human force, resulting in slower operation and greater risk of injury. The third product is a semi-automatic peeling machine, while the fourth one is a fully automated industrial machine designed for mass production. Although this automated machine provides high productivity, they are extremely expensive and unsuitable for a small or medium-sized business. Our pneumatic fruit and veggie slicer fills the gap between these products by offering a faster operation, improved safety, and consistent cutting quality at much more affordable cost than industrial machine.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazim Iskandar. My contact number is B1425200025.
Concept development. In this section, I will explain about concept generation, concept selection, final concept, bill of material, and CTQ. For concept generation, 3 concepts have been produced using prompt AI. The first one is Acap, second FNB slicer, and the last one Area Mini. Next is the phase where a concept will be selected. To select the concept, we use the path method, which emphasizes several criteria such as cutting efficiency, ease of use, safety, material quality, portability, and costing. The score were given based on the discussion of group members. Based on the path method, Area Mini received higher score. Therefore, this concept will improve the design based on customer need and preference. Next, the bill of material. The part used divide into 2 categories, which are standard part that we purchase from supplier and custom part, which are part numbers starting with PAS-0X that we manufacture by ourselves. Last part, CTQ. This is a critical part and requires high precision. Several characteristics have been identified, such as force of pneumatic, torque hole diameter, pressure plate hole diameter, and diameter of blade base.
Alright, prototype. Now that we have established our engineering specification, let's transition into how we brought this concept to life. I'm a little bit excited to present this section. The Area Mini is a semi-automatic tabletop kitchen, applies engineering to slice fruit and vegetables quickly, safely, and uniformly in commercial settings like a busy cafe or bartenders, juicy bars. Like the barista section. Manual slicing causes operator fatigue, restraint, and highly inconsistent yields. To solve this, The area mini utilized a high-performance double-acting pneumatic A cylinder to drive the mechanical cutting action. Right, the first one, the foot is placed into a custom 3D printed using a PLA base that house of a razor-sharp stainless steel blade matrix. Now, for the classify our boot, this is an alpha prototype. It is a physical working model boot specifically to prove our core mechanics in real life. Because this is an early stage engineering model, we fabricate the frame out of a 3D printed PLA plastic rather than final production materials like industrial stainless steel. We also internationally left an open side chamber. This is open configuration was critical for our engineering evaluation, allowing us to monitor tolerance under actual loads and make immediate real-time mechanical adjustment. Process flow. This section, creating a functional prototype, requires a highly disciplined multi-step engineering workflow. Let's look at the process flow we followed to transition from pixel to physical parts. Our development process was structured into 4 distinct, highly technical phases: design and CAD modeling, component sourcing and procurement, additive manufacturing, post processing and quality check. For number 1, design and CAD modeling. We began in SolidWorks, translating our concept sketches into a comprehensive 3D CAD model. This stage allowed us to generate exact engineering drawings and run initial geometric evaluation based on our target custom needs. Second one, component sourcing and procurement. Not everything can or should be custom made. We carefully selected and sourced critical specialized components online, ensuring all pneumatic actuation loop and our circle wedges cutter metric met our exact structure and fluid power requirements. Third one, additive manufacturing. For fabrication, we leverage fuse deposition modeling or FDM 3D printing utilizing PLA filament. We successfully printed out our primary structure frame components, including the robust base, shelf, the vertical guides, pillars, and the top head enclosure. And the last one is a post-processing and quality check. No 3D print is a perfect straight. Of the boot plate, we perform meticulous manual post-processing using a sandpaper to clean up the surface burrs. Then we utilize high precision vernier caliper to measure critical mating dimension, guaranteeing our assembly tolerance were accurate down to the millimeter. System assembly and pneumatic integration. Systematically assemble the 3D print base, pillars, and top head, and integrate the complete fluid power automation circuit by routing the pneumatic system to our fabricate product. Testing, evaluation, 3D and 3D design optimization. Conducted functional performance testing using a compressor A to evaluate the cylinder operation, strength and thrust capability under structural load, and successfully optimize the design by adding a custom mounting gasket to resolve a minor scaling discrepancy. Yes. Overall, this project strengthens our technical competency and provide practical experience in design, developing and improving a functional product while considering both user requirement and engineering constraint.
Before conducting performance testing, we carry out an inspection of the complete prototype. During the inspection, we check the frame alignment, pneumatic cylinder installation, blade positioning, air hose connection, and all mechanical fastener. Every component was verified to ensure proper installation and safe operation before testing began. This reduced the potential failure during the testing stage. This slide presents our ECO form and ECO log documentation. The ECO form records the inspection result, component status, and any corrective action taken during fabrication. Meanwhile, the ECO log document was the overall project progress, including manufacturing activities, testing schedule, and the maintenance record. This document helps ensure proper quality control and provide complete traceability throughout the product development process. This slide shows the Ishikawa or fishbone diagram, which we use to identify possible causes of problems during product development. The causes were grouped into categories such as machine, method, material, manpower, and measurement, and environment. By analyzing each category, we are able to identify potential issues such as air leakage, improper blade alignment, insertable material, or operator error. The analysis allowed us to take preventive action before conducting the final testing, improving both reliability and product quality. After completing fabrication and inspection, we carry out several tests to evaluate our performance of our product. The objective of these tests were to verify that the pneumatic system operates correctly, ensure there is no leak, evaluate the cutting position, and confirm that the product meets the design specification established earlier. The following slide presents the testing method, result, and discussion. This slide summarizes the testing procedure and the corresponding result. First, we performed TCO1, which is the functional test. We verified that the pneumatic cylinder can move the blade smoothly both upward and downward direction using air compressor. Next, TCO2 was the leak test, where we inspect all the air hoses and fitting. Result was confirmed that there was no significant air pressure leakage, indicating that the pneumatic system was properly sealed. Finally, the TCO3 was the precision test. We measured the slice thickness and foot width using vernier caliper. The results showed that the slicer consistently produced uniform slices with minimal waste. In addition, force analysis showed that the SC63 pneumatic cylinder generated approximately 1,299 Newton force at 60 psi, exceeding the estimated 1,000 Newton required to cut hard vegetables such as carrot. We also found that placing blade at the base allowed gravity to stabilize the product, producing cleaner cuts while preventing bruising, especially for softer fruit like tomatoes. Overall, the testing demonstrates that our prototype successfully achieved the project objective of providing a fast, reliable, safe, and low-waste solution for commercial food preparation.
So I will explain the cost and time analysis of our project. For a machine, the estimate cost during printing process was 66 ringgit 33 cents. Is only for pillar 4 pieces, pressure plate, and top. The actual cost is 268 ringgit 33 cents. Giving a variance is 202. So for the labor cost, for labor, we calculate based on salary of CEO, our project manager, industrial engineer, design engineer, quality control engineer, and sales and marketing. Overall, we work in about 68 days. So one day equals to 8 hours we work, and total of is 544 hours. The total of the labor cost was 149,192 ringgit, which matched the estimate exactly. For the material costs, such as PLA for the base, pillar and pressure plate, and top, the total was 268 ringgit 33 cents, consistent with the bill of material. For the standard part, like the air cylinder, blade, plastic, valve, and the connection part, the estimate cost is 270, and the actual cost was lower at 236 ringgit 57 cents. So saving we got RM33.43. So the subtotal combined machine, labor, material and standard part was about RM149,965 with a variance of RM235. We add 50% markup for overhead and profit, which come to around RM74,983. This brings the total project cost to approximate RM224,948. The variance was small, only RM353, showing that our estimate was very accurate. The analysis showed that our project was well planned with actual costs closely matched with the estimate and even achieving saving in standard part.
Next, I will explain our business model canvas. Our business focuses on providing an affordable, durable, and easy to maintain product for customers in the food and beverage and hospitality industry. Our main target customer are F&B business owners who require efficient equipment to improve their daily operation. To ensure smooth business operation, we work with 3D printing service provider, spare part supplier, and retail partner. These partners help us manufacture the product, supply component, and distribute the product to customer. Our key activities include designing the product, providing product maintenance, and supplying spare parts. These activities are supported by our key resource, which includes skilled manpower, investment, and quality material. Our value proposition is to offer a product that improves productivity, is easy to install, corrosion resistant, affordable, and require minimal maintenance. This feature provides customers with a reliable and cost-effective solution. To build a strong customer relationship, we provide 24-hour after-sales service, 1-year warranty, and monthly maintenance. Customers can reach us through our website, in-house sales team, phone call, and sales agent. Our cost structure consists of RM283.27 for material cost and RM277.33 for production cost. Meanwhile, our revenue is generated through product sale, service contract, spare part sale, and consultation service. Overall, the business model canvas demonstrates that our business has sustainable model by combining strategic partnership, excellent customer service, multiple revenue stream, and strong value proposition to meet the need of the F&B and hospitality industry.
In conclusion, we believe that users will greatly benefit from innovation of the pneumatic veggie and fruit slicer. This is because the integrating pneumatic technology, ergonomic safety, and commercial efficiency. Our design ensures that every slice is perfectly uniform, enhance premium food presentation, and reducing waste. By implementing a two-hand safety stud, the product significantly minimizes workplace accidents, making it safer for F&B staff and hospitality staff. We would like to highlight in this space, the pneumatic fruit and veggie slicer is not only suitable for high volume use, but also represents a measurable improvement in labor savings, safety, and food quality. With its combination of advanced engineering and practical application, the product fulfills the objective set forth and demonstrates strong potential to transform fruit and vegetable slicing in commercial kitchens environments. In summary, our innovation embodies efficiency, safety, and precision, delivering a modern solution that meets the evolving needs of the food and beverage industry, also hospitality industry. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.